How are you guys? This is me, Mr. Assam Zidane, and today we are going to explain the wireless communications. Last session we have explained waves of electromagnetic spectrum, and I told you the electromagnetic spectrum consists of 7 different types of waves. The first one was radio wave, then microwave, infrared, visible light, ultraviolet, X-rays and gamma rays. So all of these types has a certain range and has a certain frequencies and a certain energy, and all of them have the same velocity. Also, we know that there is a relation between frequency and wavelength, and the relation between them is inversely proportional, which means when the frequency increases, lambda or wavelength decreases as well. So today we are going to speak in more details about radio wave and how do radio waves transmit information. All of us know the radio, all of us know the broadcasting. When someone just speaking in broadcasting station, so what happens? Actually, guys, what happens if there is someone here, he just is speaking in this broadcast, so his sound converts to radio wave. Radio wave. So when the sound converts to radio wave, so the antenna, the broadcast antenna, just vibrate and spread this radio wave all around. The transmission antenna send out radio waves in many directions. As you can see here, it just send it in many directions. So all the radios receive it. All the radios at home, in your cars, okay, as you can see here, can see it and can predict it. So what happens inside the radio? Inside the radio, so the radio waves converts to electrical signals, and these electrical signals converts again to sound, so you can hear a song or something like this song, or someone is speaking. So in a broadcast station, broadcast station, okay, so the sound converts to sound becomes radio wave, and this radio wave by the broadcasting antenna just spread everywhere, and this radio wave inside the radio device just converts to, inside the radio device, converts to sound, so to electrical signals. Here it's electrical signals, and these electrical signals converts again to sound. So these are the steps. First, the broadcast antenna, okay, just vibrate and send the sound as a radio wave. So the radio wave is spread everywhere. So the antenna of our radio in our cars and at homes just receive this radio wave, and inside the radio device there is a part which is had the responsibility to convert it to electrical signals. Then this electrical signals converts to sound, so you can hear a song, or you can hear a song, or someone is speaking as well. Also, guys, there is two types of electromagnetic of radio wave. There is two types of radio wave. We have AM and FM broadcasting signals. And as you can see here in this part, the difference between AM and FM. AM, this abbreviation for amplitude modulation. Amplitude modulation. So this is amplitude modulate or modulation. Okay. So as you can see here, the difference between all of AM, okay, is about the amplitude. So the difference between amplitude AM has a relatively long wavelength within low frequency. So this one has a relatively big wavelength within smaller and constant frequency. So the frequency in this case is constant, and the difference between the different types of AM broadcasting wave is the amplitude. So each one has its own amplitude. But what is the advantage for this AM broadcasting wave or signals? It's easily to be reflected back to the Earth's surface. Why? Because by ionosphere region of charged particles in the atmosphere. So when this is the Earth, and around the Earth, this is the atmosphere, and in this atmosphere we have different layers. So here in this part there is a layer is called ionosphere. So this ionosphere, from the name, it's ionosphere, so it has ions. So ions means charged particles. So this one has a charged particles, and the name for this one is ionosphere. So because this wave has a very long wavelength, so it had the ability, this ionosphere just reflected back to the Earth, so we can receive it, which means it sent from the Earth, hit the ionosphere, then it come back again, which means it had the ability to cover a great and huge area. Also, this means it can just travel for long distances. So if you have the ability to just hear from the sound or the broadcast from another country, this is probably by using AM. About FM, the situation is different. FM has a constant amplitude. So here amplitude is constant amplitude. And the difference between the different ranges of the FM, okay, is the frequency. So it has different frequencies. So the frequency, the one which recognize, or we can just recognize between different different FM signals, is about the frequency. So each one has its own frequency, and this one has of course has a higher energy because it has higher frequency, and it passes through ionosphere instead of reflected back. So when this one is sent, okay, when this one is sent, the FM signal sent, because it has a greater energy and has shorter wavelength, so it had the ability to just travel and pass through the ionosphere, just can travel and get out of the ionosphere, so there is no reflection. But so it can't travel to greater distance, so we use it at the same town, at the same cities, okay? But the point why we use it, because it produces better sound quality than AM waves. Radio spectrum. Also, guys, in radio spectrum, radio, we don't have in radio, when I told you radio wave, it doesn't mean it has a certain number of frequency and wavelength, but it has range. So as you can see here in this table, okay, so we can explain this. For example, we have very low frequency, medium frequency, higher frequency, very high frequency. So it's a range. So the range here in the frequencies between 3 kilohertz, so 3000 hertz, to 300 million hertz, 300 gigahertz, which means it's 300 million hertz. Also, because it's corresponds to this frequencies, we have a wavelength. It's from 100 kilometers, so this is the wavelength. Start from 100 kilometer to 1 millimeter. So 1 millimeter. Also in this radio spectrum, because it has a lot of ranges and a lot have different frequencies and different wavelengths, so we can use it in many uses. It can be used in radio stations, as we have explained before, in between the policeman to just by using the radio. And how does a cell phone work? So the cell phone, okay, it's working as we explained in the previous lesson. It works by using microwave, which has a greater frequency and a greater energy than radio wave. So when placing cell phone, the phone send out microwaves. So when you just do a call, so the phone send a microwave, which are tagged with a number unique to your phone. So each phone number has its own frequency. The tower picks up, as you can see here, so the tower just picks up the signals, then it transfer it to the hub. Okay, so this is the hub. He just transferred this signal. So the hub send it to the receiver of another mobile, so this one can receive it. So it's very simple. Just when you just click a call or dial up a certain number, so these signals move to the tower, and the tower convert the signals to microwave, then from the tower to the hub, and then from the hub it sends it to another tower or to the receiver directly. It depends on the distance between the two cell phones. Actually, how do satellite communicate work? We use satellites for different purposes. One of them is for radio wave and TV. So we can just transmit a match between America to our country directly, or live transmission. The reason for this, or how can we do this, by using the satellites. So how the satellites work? The satellite actually work so by sending the wave. So this is the earth. If there is someone here on the earth, okay, he just transmits. So this is the satellite. So we just send the signals, TV signals, radio signals, okay, to this satellite. So the satellite take the signals and deliver it to another place in the world. And because the speed, it's incredibly high speed, it's about 3,000 times 10 to the power of 8 meter per second, which means this wave had the ability to travel 300,000 kilometer in kilometer in 1 second. So this happens very short time to just deliver it in any place on the earth. Also, we use it in cell phones, okay, and also we use the satellite in a global position system. Satellite used in a global position system, GPS. So GPS is abbreviation for a global positioning system, global positioning system. To just know the for this system we are using 24 satellites. So as you can see here, we have almost 24 satellites. So the 24 satellites broadcast radio signals to the Earth. So for any location, the satellite always send the signals to the Earth. So he just sent the signals as a radio signals, telling you exact the location by using four satellites. As you can see here, to determine the location for this guy at any location or at any position on Earth surface, so we use four satellites. Three of them determine the location. So the three of them just determine the location, and the fourth one tell you how far above the Earth. And this one just tell you how far above the Earth you are. How far above the Earth. So the airplane can use this one. Why? Because it's already above the Earth's surface, so it needs to determine 2 points. Okay, it needs to determine the location. So this one give us GPS. So the GPS gives us, okay, the location and how far above the Earth surface, altitude or your height above the Earth surface. Okay guys, this was the end of our session today and I hope you understand that. Thank you very much.